Mike from MotoIQ here, and today we're going to finally talk about one of my favorite engines of all time, the Honda B-Series. Now, the B-Series is sort of the workhorse engine that kicked off the whole import revolution back in the day, and there's a reason for that. It's a really good engine, and it was really quite ahead of its time when it came out. It has Honda's excellent VTEC system, which is variable cam timing. It doesn't just adjust the phasing, which is pretty typical nowadays, but there's actually high and low RPM lobes. But we'll get into that a little bit later. Like most of our engines, let's start with the bottom end and progress through the whole thing. Now, this is a B18C5. Now, I really like the B18C family, but the B18C5 is a historically significant engine. It powered the Integra Type R, and it had a lot of work done to it from the factory, and it was pretty decent motor. But we got the honor of helping someone with his Type R resto modding, so we built a pretty healthy B18C5 here, and here's what we did. Starting with the block, basically we've sent it to CTP Cryogenics and had them apply their latest aluminum cryogenic treatment. Now, I don't know what this is. They're really secretive about it, but it's way better than the older style of aluminum cryo treating. It's something they just figured out this year, but it supposedly really increases the actual strength and fatigue resistance and wear resistance of aluminum. It's very different. I don't know the metallurgical details. Generally, when you cryo treat aluminum, it's really good at stress relieving it. But I don't understand the metallurgy compared to how I understand the metallurgy of steel parts. But they swear it's a lot better than what they were doing, and they don't want to talk to me about it. So we'll just assume it's really good. The cryo treating does improve the metallurgy of the various cylinder liners. Like it goes from a face-centered cubic structure to a body-centered cubic. It's a martensite, and it's a harder, more abrasion-resistant crystalline structure of steel and iron. So you get some of that conversion, so it really helps wear resistance. It also helps strength and all that. In the block, the wear resistance is the most handy thing, and the stress relieving, I would say. The B18C has a die-cast aluminum block, so there's not a bunch of wasted material like you see in sand casting, and you get a little bit better grain with die casting over sand casting because it's a high pressure process, and you get a smaller, more refined grain from the factory. It's also a very well designed block. It has a main cap girdle, which really helps stiffness and strength, especially for turbocharged engines. This is a naturally aspirated engine, but it's still really strong. This all comes from the factory like that, so it's the good basis of building a lot of sick power. Now, it's an open deck block, and maybe that's the only real drawback to the B-Series. For a naturally aspirated engine like this one, we'll leave it open deck. Even for turbocharging, maybe up to getting deep into the 500s, the open deck is fine. Now, if you're going for a really huge power and high boost, it's better to do a closed deck conversion, and like a proper closed deck conversion where you actually CNC machine the upper part of the block and put a register in, and actually install a precision closed deck plate into the water jacket, and then machine it all flat. Like in the past, they had these things called block guards for these engines, and it was just basically hammering a piece of metal to kind of close the deck up, maybe about a centimeter down. Now these are like awful, like they actually distort the cylinder wall quite a bit, and they don't really stay in place, and they're kind of useless. So there's a lot of block guards on the market. Don't use any of them, in my opinion. Do a proper closed deck conversion if you're running big boost and big power. Now, since this is a naturally aspirated motor, we use the stock Honda bolts. Now, I don't really believe in using studs unless you're going for big boost and big horsepower. I'd rather use the factory torque to yield stuff. A lot of it's because you're getting an aluminum block, and the aluminum block grows twice as fast as the the steel studs. And if you have a high strength stud, the block will grow way more, so your point torque load goes up quite a bit. The deck can distort, the cylinder head can distort, and you can actually lose sealing. So unless you really need to prevent the head from lifting, I just recommend using stock bolts. So that goes for just about any NA build. We machined the block. We did an align hone. This is, for a Honda, they usually don't go out too much. So it's just a light honing down the main boards to make sure they're all concentric, straight, and consistent size, so you get good bearing crush. We also bored it a 0.5 millimeter oversize, which is the max I think these stock liners can go to. We used a torque plate. A torque plate is a big stiff metal plate with holes in it that simulates the torque of having a cylinder head bolted down. So it distorts the block in a similar way to installing the head. You do all your machining with the torque plate in place and let all the distortion occur. That way when you torque down your head, your cylinder wall is perfectly round. Now, this isn't like absolutely critical on the Honda engine. On some engines it's mandatory because they distort so much, but these don't distort too bad. If you're building a high boost engine with studs, closed deck conversion and things like that, they are pretty mandatory because you're dealing with basically changing the structure of the block and having really high clamp loads that's really good to distort things. So for sure for like high boost applications, but even with the naturally aspirated engine, every bit of ring seal and concentricity you can get counts. So we torque plated. We torque plate almost every one of our builds unless the customer specifies otherwise. But the other final thing we did is after machining, we WPC treated the cylinder walls. Now, if you watch our video, we use a lot of WPC treatment on our serious builds. WPC treatment is like a Japanese micro shot peening process where they use really small ceramic balls shot with a high velocity, and they mix dry film lubricant stuff in there, and it's kind of secret. They won't tell us exactly what they do, but you end up with a super smooth, micro-hardened surface finish. It puts a compressed, fine-grained surface on the metal part, just like I guess shot peening does. It actually changes the grain of the metal down like maybe 0.5 thousandths into the metal. And this is really smooth, really wear resistant, really helps fatigue resistance too. Almost like everything shot peening does, and it has the even better surface finish. And the also the dry film lubricant gets impinged in the surface and kind of mixes in there, and that helps wear as well. So WPC, we do a really fine finish on the deck surface, which is important anytime you use a MLS type gasket. So I mean, you can see it's almost like a mirror. That's what we did with the block. Now this block was in pretty good shape. If you have a crusty looking block and it's going into a restoration, we can vapor hone the outside of your block and it'll look like brand new. I mean, this block was really clean, so we didn't opt to do that, or the customer didn't need it. But we can do that, and vapor honing can turn your ugly cast aluminum into awesome stock new looking stuff. And it's not that gray finish that gets fingerprinting and stuff like bead blasting or sandblasting does. It actually looks like a brand new cast part. For our head gasket, we're using the Felpro Pro Seal gasket. It's a high quality MLS gasket, so it's 3 layers of stainless. It's embossed to get good sealing, and it's polymer coated. For a turbo engine, I'd probably do a little bit more exotic gasket, but for naturally aspirated, this is a fine gasket. It's heavier duty than stock, and it'll get the job done. The next thing I guess we can go into is the crank. Now the stock B-Series crank is a really good crank. It can handle tons of horsepower, way more than what an NA build can throw at it. Like unless you wanted to stroke the motor, I'd say there's absolutely no need to use an aftermarket crank. It's fully counterweighted, super stiff, good journal overlap. This thing is stout. It can probably hold 800 horsepower or something, I bet. But what we did is we precision balanced the crank, and then we also micro polished the journals. Of course, we did Magnaflux and stuff just to make sure it was in good shape. Magnaflux is an X-ray crank detection process. We then cryo-treated the crank, and we WPC treated it. So you can see the really lustrous, smooth look of the journals. That's the WPC treatment. If it has a slight bit of blotchiness, that's due to the stock nitriding. The nitriding looks blotchy after you WPC it, and it's not really a problem with the WPC. It's just how nitriding looks once you WPC it. But this is a great crank, and it's ready to go. The next thing we do for most of our really serious builds that are going to rev high or make a lot of power is we use a fluid damper harmonic balancer. Now a lot of people use lightweight pulleys, and in my opinion, for most motors, those are okay, especially if it's a street car with near stock power. But when you get big power, really high RPM, fully built motors, you need that balancer, and the fluid damper does a super great job. I mean, the fluid damper really kills vibrations. Like your stock damper is usually like a pulley and has a center hub and has an inertia ring around the outside that's bonded with rubber to the hub. And usually that is tuned to help damp out a certain harmonic at a certain RPM. But the fluid damper, it works way different. You have a hollow steel housing with a floating steel inertia ring inside like that. And the inertia ring floats in this silicone goo here. Now you can see we have a ball bearing in there, and the ball bearing doesn't sink. So this stuff is kind of sticky like snot or something, and it has some viscosity to it. So, like the steel ring is floating inside this housing full of this snot. And what that does is, it's totally free to move. So, the harder your crank whips, the more the damper works to absorb the vibration. So your stock damper is kind of frequency dependent. The fluid damper is amplitude dependent. So it's not so much tuned for a particular frequency, but, the harder your crank is whipping and the more vibration, by nature, the harder it works. And, we've used these from anything from stock motors to 1,000 horsepower motors, and it's pretty amazing about how much smoother they are. In some motors, they get quite a bit more horsepower, like a Subaru FA motor. You know, they give 6 to 8 more horsepower. Other motors, you know, like a 4G Mitsubishi doesn't respond that great, but it does make it a lot smoother. And when you're getting the big horsepower numbers, you know, that helps for durability and can free up a little power. But like a stock 4G, no, it's mostly the smoothness. Other motors, depends how bad the vibrations are, but you know, I think they make a significant difference in life. You know, if your car uses a crank trigger, it usually frees up some power because you get more accurate timing. And with less vibration, things are fighting each other less. So any high RPM, high power build, if fluid damper has the application, we're running it. For bearings, on this particular motor, we're using King XPC. These are one of our favorite bearings. Now, I didn't lay out all the bearings, but you know, a bearing kind of looks like a bearing. What we normally do is we have all of the King bearing shell sizes. So when we're setting the clearance in each journal, we may mix and match a couple of different shells to precisely control the oil clearance. We use the XPC bearing if there's an application. This is like a tri-metal bearing, so it has a steel base shell, and then it has a really hard layer, which is you know, lead and some other kind of soft metals, but it has a pretty high tin and copper content. So this makes the bearing pretty hard, and it increases its load bearing capacity, which is, you know, how much load you can put on it before it squishes out and spins. The top layer is a slightly softer layer, so it's a higher, softer metal content like lead or something, and the alloying elements aren't such a big constituent, I guess. So what this does is it gives the bearing some embeddability. So if you get a piece of crap in your oil, it can embed itself in the softer upper layer and not dig a groove into your crank so bad. You know, soft, like OEM kind of bearings are maybe a little better, but this is better than the super hard bearing. The third layer is King's exclusive polymer coating. So this is like a polymer, so it's generally something like a Teflon kind of coating, but the big difference is the King bearings use copper nanoparticles in there, and the nanoparticles are really fine, so they don't mess up the lubricity of the polymer, but they really stiffen up the polymer and give it more load bearing capacity. So your typical coated bearings, maybe they're for friction reduction and you know, scuff resistance on initial start, but the King's polymer coating is actual structural, and it helps load bearing capacity. So it's kind of cool and unique as a polymer coating. We're using King thrust bearings. There's nothing particularly special about them, but they are a high quality thrust bearing. The thrust bearing goes on this journal, and it controls the clearance for the crank to walk back and forth. Not a big deal. I guess we can keep on going with the bottom end. For pistons, we're using JE FSR pistons. Now, I really like the FSR, mostly because of it has an asymmetrical skirt. So as you can see on the thrust side, it's a really big wide space, which you know, like imparts more surface on the cylinder wall. You know, this kind of reduces piston slap, helps keep things quiet, can help the piston stability in the bore. That can give longer life, less friction, etc. Now you look at the other side, the non-thrust side. This side is more lightly loaded, and it's all cut down like, you know, a full race piston, so it's narrow. This makes for a lighter piston and less friction, but since it's lightly loaded, it can be aggressively cut down. Like you've probably seen full race strutted type pistons that have something like this on both sides, but that's not so great for a long duration use like road racing or the street, and they tend to be noisier. They're harder on the cylinder walls, etc. They make for a lighter, low drag piston, but for like everyday use, they're not quite as good. The JE piston also has an offset piston pin, which helps more gently lay the thrust surface of the pin into the cylinder walls. So this greatly reduces noise and that slapping sound, and helps bore stability. Like a lot of other piston manufacturers don't have the extent of offset that JE does. I mean, you can almost see it there. And we found that JE pistons are really quiet. The piston alloy that we're using is 2618. Now that's a low silicon, really tough piston. This is really good for strength. Traditionally, 2618 pistons are more noisy. This is because they grow more with heat, so they have to run a bigger piston to wall clearance. So this means more noise, less bore stability, shorter life. But JE has the offset pin, the FSR face here, and they have really good cam profiles. They've done a lot of computer-aided design, FEA, and thermal analysis. So they have a really good cam shape of the piston. Now the cam shape takes into account how the piston is laid into the cylinder wall as it's going round and round. It also looks at the thermal load and the coefficient of expansion of the metal. So the crown is going to grow more than the skirts because of the combustion heat, and the cam shape takes all that into consideration, that growth you have. So JE has done a really thorough analysis, and we've found is their 2618 pistons are like probably the quietest on the market, and we don't have too much of a problem running them in the street car. Like if someone's really picky and they want something really quiet, we might spec 4032, but almost everybody will be satisfied with the JE 2618. The piston has some other cool features. It has a pressure equalization groove between the number 1 and number 2 rings. You get a little bit of leakage past the first ring, and the groove acts like a pressure reservoir to make sure there's a continuous pressure supply to the number 2 ring to help it seal better. It also kind of acts like a buffer zone for any like detonation pressure waves that might make it past the first ring, to help keep ring seal, even though like there's a lot of that pressure and weird stuff going on. The forging itself is a really good part. Now JE invests in making a lot of forging blanks for a lot of their applications, so you get a near net shape blank. This means that you have optimal compactation of the metal during forging and good grain flow. So the grain goes around the piston pins, so it acts like grain of the wood. So it's really hard to snap wood when you bend it against the grain, but if you bend wood with the grain, it's a lot stronger. Same thing with getting the good grain orientation of your piston with a proper forging blank. So you get a near net forging, doesn't require that much post-forging machining, and you get optimal grain flow and optimal strength. As far as compression ratio, we're running a little bit more than 11:1. Now a lot of guys say, oh, you can run 12:1 and run on 91 pump gas and no problem. It's been our experience, pump gas can vary, and it's best, especially with California's crappy gas, not to try to go to the last bit of compression ratio. I mean, we've seen 12:1 engines with a conservative tune show signs of detonation. So, give up 5 or 6 NA horsepower and not worry about it. But overall, it's a really nice piston. You know, this happens to be a shelf piston, but I wouldn't hesitate running it in anything. It has like really good features that a lot of custom pistons don't have. For the piston pin, we're running JE's standard straight wall piston pin. I don't really believe in running like tapered super thin pins because a lot of times with high load they'll like flex and they'll you know, screw the small end bushing out of the rod. So I'd rather sacrifice a little bit of weight and have a stiffer pin. The pin, the piston, the rings have all been WPC treated for long life and low friction. What I really like about the piston is when you WPC the grooves, you get a nice hard dimpled surface in there and you're less likely to get micro welding. Your rings are a lot freer, they move around nicer, and you get better ring seal and ring life. Now the piston rings are JE standard rings, which I think are pretty cool rings. The #1 compression ring is really thin, really low tension. It's steel and it's nitrided. The nitriding gives a really hard, low friction, long wearing surface. The #2 ring is iron. It's also thin and low tension, and it has a Napier profile. A Napier profile means it has kind of like a hook at the bottom of the ring. Now the hook helps seal. Like the #2 ring receives less pressure than the #1 ring, and when you have a little thinner hook, you get a better sealing load against the cylinder wall with less pressure. Also, that little thin edge on the softer iron ring kind of beds in quicker and wears into the cylinder wall faster, so you get quicker initial seal on startup. You know, that doesn't mean the ring doesn't last long, but it works better in that application. The oil rings are narrow, low tension. You know, they're low tension oil rings. What can I say? They have a generous amount of drain back holes on the pistons, so they'll be able to effectively scrape the oil off, and you know, you won't get an oil burner, you know, if everything's clearanced correctly. You know, we really like the JE piston and ring package. You know, it's their FSR skirts, their offset pin, and their barrel contour that makes all the difference. We think they do it better than probably anybody in the industry. There's plenty of other companies that make great pistons also, but for the combination of streetability and performance, we really like JE. Now for rods, we're using boost line rods. I've been liking these a lot lately. Now they have a kind of a weird look and shape, but you know, this is the result of extensive FEA analysis. So this shape actually gives more strength and stiffness than your traditional H or I beam. You know, it looks a bit different. I think, you know, they're a really good price. They're made out of 4340. Now that's a high nickel and molybdenum steel. So this means it's super tough and super strong. The properties that you want in the connecting rod. It's like, think of it as chromoly plus. It uses ARP 2000 bolts. These are really strong bolts, great for a naturally aspirated application. And they're pretty reasonably priced too. So it's a high quality rod with a good price. Now, if you're going for a super full race naturally aspirated engine that's going to rev to 10 plus grand, they're maybe a little bit on the heavy side, but this engine probably won't see more than 9. And to me, these are great rods, perfect for the application and a great value. They're really good in turbocharged applications too. Like you almost can't get a better rod than these for turbo motors. You've probably seen these rods on some of our other turbo builds, but they're not bad for naturally aspirated either. Now we're going to go to the cylinder head. For naturally aspirated engines, the cylinder head is the heart of your power making. This is B18C5 head. So what's cool about this head is that it's ported from the factory. So Honda on their Type Rs actually did some port work. Now when you look down like from the gasket side, intake and exhaust manifold, they don't like super look ported, but that part of the port's not really imported for flow. They're ported a lot in the bowl area and the entrance into the ports. So when you see the porting here, that's actually factory Honda. And they've done a great job of rounding the floor humps, opening up the entrance from the valve bowl into the port. You know, like 95% of your power is going to be found just there. Like, you don't really need to enlarge the entrance and exit of the ports unless you're making really, really big power with more displacement. On a super nice Rustomod motor like this, that kind of stuff will just reduce your bottom end. The factory Honda porting is great. If you have a regular, like a B18C1, this level of porting is like something we would do. But in this case, the Honda factory's done it for you. Now we've gone like one better than the Honda factory. So we've done a valve job with the Newen CNC valve grinding machine. It doesn't really grind the valve seats. It actually uses a CNC cutter. And what that does is it makes a smooth radius from the cylinder, the combustion chamber. It has a 45 seat that's straight, of course. It's not a radius. But then the radius resumes at the 70-degree throat cut, and it extends into the port. So you have a nice smooth contour with no anything that can disrupt flow. Now this generally gives more flow than a 3 or 5 angle valve job, which you've probably heard. And it actually opens up the port seats and gives more area. On a lot of engines, going from a conventional valve job to a Newen valve job can be as much as 50 horsepower. I think on a naturally aspirated motor like this, it's more like 5 or 10, but that's still a pretty good step up, and it's free power. When you look in here, I mean, you can see the smooth contour. It's pretty beautiful. For valves, we're using SuperTech performance valves. On the intake, we're using their nitrided stainless. It's like a flat contour. So when the intake flow is coming this way, this kind of contour helps the flow make the turn to the combustion chamber more easily, and it improves flow. You can see that the stem diameter is reduced here. That also helps flow. These are really high quality valves. We use them in almost all of our builds. For the exhaust valve, we're using SuperTech Inconel valve, and this has more of a like a tulip shape to it. So when the flow is coming out of the chamber into the exhaust port, this tulip shape helps the gas change directions that way better. You can kind of see the difference between the intake and exhaust contour here. So this tulip shape helps flow. The stem is reduced slightly. Like, you don't want to go overboard on the exhaust valve because the exhaust valve runs a lot hotter, and you need some stem to conduct heat out of the valve so you don't end up burning it. The valve is made out of Inconel, which is a steel alloy with a lot of copper and nickel in there. It's like an aerospace alloy that's super heat resistant. Good stuff. So stainless, Inconel, SuperTech, they're 1 millimeter oversize. So the oversized valve gives a lot more area on the seats, so you have a lot more low lift flow. And the slight oversize also enables us to cut the seating surface, the 45 degree, really high on the seat. So the valve sits high and into the chamber. This really helps low lift flow too. So, you know, like, we were doing a great job of restoring and improving this super classic head. It should be pretty awesome. For the valve train, we're going to start with the camshafts. We're using Kelford 176B cams. Now this is a great cam for a like serious but maybe not full race motor. Like it can pull solidly to 9,000 RPM, but it'll still have good bottom end, good mid-range torque, and good idle. The VTEC system enables this. Like it has a low RPM lobe for putting around and a high RPM lobe for going fast. This cam is 284 degrees of intake duration and 280 degrees of exhaust duration, and has 11.8 millimeters lift on the intake and the 11.4 on the exhaust. So it's a pretty short duration but high lift cam. And Kelford's valve kinematics allow this kind of fast valve motion. This gives you a lot of area under the curve, and area under the curve is what makes power. Other guys do it with less lift and more duration, but more duration generally tends to make your power band higher and more narrow. So these cams ought to give a nice fat power band and really good street characteristics still, which kind of complements the nature of this build. We cryo-treated the cams and WPC treated them for long life and low friction. These cams should be a great complement for the overall theme of this engine. Now the cams require stiffer valve springs. Now when I specify like a cam and spring combination, I really like to stick with the manufacturer's recommendation rather than go to a kind of universal aftermarket stiffer spring. The reasons for this is like cams that are more engineered by a company that's more engineering intensive will actually match the cams, the valve train's natural frequency with the frequency of the spring, and that way you can passively reduce the chances of spring surge. The old redneck way is just up the valve spring tension till it quits, then you don't get valve float. But the correct engineering way is to look at your higher order harmonics, identify the problem ones, and design the natural frequency of your valve springs to try to avoid those areas. Now you look at the Kelford spring, it's made out of a really high grade wire. They're shot peened after manufacture, and the inner spring is like an interference fit with the outer spring. Now this interference fit works to damp harmonics, and like you see sometimes the inner spring's just rattling around, but in this case there's actually contact between the inner and outer, which acts like a damper, which reduces the chances of surge. The springs also have a precision valve seat that really locates the inner spring, and a titanium retainer that's lightweight, wear resistant, and you don't want to have excessive reciprocating weight because that can lend itself to spring surge in itself. We have the Honda rocker shafts. They've been WPC treated and cryo treated for better wear and low friction. Now for the rocker assembly, Honda no longer makes OEM replacement rockers. So what we did is we got the Skunk 2 rockers. These are a pretty good approximation of the OEM rockers. It has appropriate metallurgy so you don't have galling. And perhaps the best feature is the Skunk rockers, the pads are wider. So if you have a more radical aftermarket cam, you don't get anywhere close to the lobe running off the edge of the pad. Like a lot of times if you use the stock rockers and with a really big cam, like the cam rubs right to the edge of the pad and you get accelerated wear. Well, the Skunks are like bigger there, so there's more leeway. We were kind of scared of WPC treating these, so we didn't. I was sort of worried about grit contamination of the loss motion plunger in here and decided to play it safe. Now this is a customer engine, so wanted to play it safe. My own personal engine, I probably wouldn't have a problem with experimenting with it, but I didn't want to risk that on an engine that you know, we're building for someone else. For the timing belt, we're using a Gates RPM belt. Now these are Kevlar, heavy duty, and way stronger than OEM. And they make them for most popular performance engines. Like we use these on Subarus and Mitsubishis a lot. So it's a great belt, reasonable cost. You know, actually, if you're replacing your stock belt, this is a good choice. Finally, the owner of this car wanted an intake manifold that resembles the stock one, but has a little extra. So one of the best manifolds for this kind of use is the Skunk 2 Pro manifold. It looks almost factory, but it has like bigger, slightly shorter runners, and it's been CFD designed and everything, and it's tested, and it's shown to give like maybe just under a 10 horsepower gain on a pretty built B series. Now we went a step farther, and we had the manifold extrude honed. Extrude honing pushes a abrasive paste through the manifold. Now, this is like a polymer paste with tungsten abrasive in it, and it's shoved through the manifold at really high pressures. And what it does is it actually rounds out the manifold, radiuses the inlet of the runners from the plenum, and it actually enlarges the runners, and in areas of high velocity where there's a restriction, the media actually cuts faster. So it actually like kind of improves the flow and blueprints everything just by nature of the process. Now extrude honing was really popular like maybe 10 years ago, and people don't talk about it a lot. I think it's because there's, you know, most of your popular performance engines all have like performance intake manifolds built for them. But you know, if you're running the stock or a stock-like intake manifold, or if you're running your cast exhaust manifolds for like a turbo car, for instance, and if you have a turbo and you want to improve the flow of the exhaust housing, and even the intake housing on the turbo, I think extrude hone is the way to go. So improving the flow of hard-to-access castings is where it shines. On a B series that's pretty healthy, extrude honing's been found to give like 5 to 8 more horsepower. In a naturally aspirated engine, every little horsepower you can get is, you know, like huge. Now, I think this engine will end up producing probably 245 or so horsepower on pump gas. Now that's pretty healthy for a B series, and I mean, man, I would want this motor in my Integra. It's super awesome, and it complements the whole retro mod thing on the car. Yeah, the guy that's getting this is one lucky sucker. I wouldn't mind having it. So there you go. Finally, we talk about the B motors. I know a lot of you guys have been asking about this video, and you got it. So if you like this content, be sure to subscribe to our channel. Go to MotoIQ.com. We have a lot of B-Series content on our website, and builds. We did a lot of them back in the day. If you like this merch, if you want a cool t-shirt like I'm wearing, and we have a few other designs as well, I should really wear them in some video. Go to MotoIQ.com, hit the shop icon at the top, check out our web store. If you need parts for your car, we also sell most things you need on our web store as well. So go ahead and get your parts there. Your purchases help fund our content, so we very much appreciate it. So until next time, let's build some cool motors.